were able to draw a Venn diagram of this? One. Anybody else? Okay, how many of you were able to draw a Venn diagram of this? Okay. You guys get this chart written down? Okay. How many people did both? How many people have both a curfew and chores? 13. How many people have a no curfew but chores? 5. So how many total people? Okay, how many total people have chores? 18. 13 plus 5 makes 18. Okay, how many people have no chores but have a curfew? 12 people. And how many have neither a curfew nor chores? 3. And so 12 plus 3 makes 15 with no chores, right? Okay, how many people have curfew? Draw the Venn diagram? I'm going to do that in just a second. But I want you to understand these numbers first. 13 and 12 make 25. 5 plus 3 make 8. How many total people are there, you guys? 33. How'd you get that? Yeah. If you go 18 plus 15, that's 33, or 25 plus 8, that's 33. It should add up both ways. Okay. To make your Venn diagram, you're going to draw your rectangle with 2 intersecting circles like this. Okay? Okay? Okay, now we're going to fill these in. Now, you guys, one of these circles represents people who have chores, and one of them represents people who have curfews. There's a certain number. We're going to put a number in here, 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 and out here. There's a certain number that has to go in here. Now, I want you to look at that table again. It goes in the intersection. Which number do you think is going to go in that intersection? Huh? Someone said 13. Why do you say 13? Yeah, it's the people who have both chores and a curfew. If it makes sense right here, if I put 13 right there, doesn't that make sense that those are the people? They're in both circles. They have a curfew and chores. What was that? 3 is, what do you mean on the outside? Outside of the circles? Yeah. 3 would be the number out here. These are the people that have neither curfew nor chores, right? Those are the lucky people. I don't know. People like that grow up and they don't have any discipline.
I have discipline.
You don't have curfew or chores?
No.
You never have to work? Your mom and dad never have to do any work around the house, help out with anything? They just feed you and make your bed and clean up your room? Do your laundry? Okay, so those are chores. Okay. Huh? Well, guess your definition of chores. Okay, you guys, what number would go right here? Why 12? These, well, that says chores. 5. Okay, these are the people right here that have chores but no curfew, right? Okay, chores but no curfew. What's going to go right here? 12. These are the people that have a curfew but no chores, right? Does that make sense? That's all you have to do. Now, on the test, you're going to have a problem like this where I'll give you guys a table like that, and I'm going to have you guys write a Venn diagram like that. Now, keep in mind, the people who have both things, or whatever it is, because I could put any 2 things on here, okay? The people who have 2 things are going to be the intersection. That's going to be where the circles intersect, right? They're both of them at the same time. They got to be in both circles, both subsets, okay? This number 5 right here went for the people who have a chore but no curfew. And 12, a curfew but no chores. Okay, and so that's the 5 and the 12 right here. They're still in one of the circles, but not in both of them. And then the people who have neither are going to be right out here. Okay? And that's what we have. Okay, does that make sense? hopefully that will help you do your worksheet a little bit better. I want everybody to pull out your packet, and we're going to do problem 7 together right now. And hopefully help you have some understanding right here, okay? Problem number 7 gives you, if I remember right, problem number 7 gives you a Venn diagram that looks like this. You have a circle A and a circle B. And you have small a, B, C, and D is out here, okay? And it gives you an example. It says probability of A. By the way, you guys, you need to know this definition right here. Okay? That means probability of A. Everybody read that. Probability of A. Say that. One more time. Probability of A. Okay, the probability of event A happening is equal to A plus B over A plus B plus C plus D. Now I'm going to explain what this means, okay? Now, the probability of event A happening, that's what this is talking about, is going to be the number of desired outcomes over the number of possible outcomes. If I look at this right here, what letters are inside of event A? A and B, right? So it's going to be A plus B is my number of desired outcomes. That's what they wrote up here, A plus B, right? Now, what's my number of possible outcomes? A plus B plus C plus D. It's all of these things, okay? And that's the number of possible outcomes. That was kind of an example for you. So I want you guys to look at part A down here. What is that? In Roman numerals, I. And it wants to know the probability of B. I'm going to give everybody 30 seconds to write down the probability of B. Base it on what we just learned about the probability of A. And then we're going to check to see if you got it right. Look at this probability of A. Look at which numbers you got. Follow that example. That's the probability of A. It's very similar, except for it's different letters on the top. Okay, everybody check it with your shoulder partner. See if you got the same thing. Everybody right now, check. Go ahead. Go ahead, Lacey. You can put that down and go ahead and check. With Shelton. Shelton, show her what she got. She hasn't done hers. She doesn't have her packet open to. Okay. Anybody think they've got it? Raise your hand if you think you got it. Natalie, anybody else? Kyle? Okay. Anybody else think they have it? Dean? Okay. You guys look. The probability of getting A was everything inside of A. A plus B, right? All over all of them. So the probability of B happening is everything in B. What's in B? B and C are inside here, right? Aren't these? Here's circle B right here. Here's B and C. So B plus C all over the number of possible outcomes. A plus B plus C plus D. Got it? Okay. Let's go on to Roman numeral 2. Probability of A and B. Now keep in mind, we learned what the word and means. What does that mean? Which symbol was it? Has the upside down U, right? That's called an intersection. In other words, we want to know a probability of both of them happening at the same time, that they're going to be invent A and B at the same time. What's the probability of that one? I'm going to give everybody 30 seconds to write that one down. Show your shoulder partner and see if you got the same thing. Okay, how many of you think you got something that works? Okay, more of you this time. Good job. What'd you guys get? No, remember, it has to be both of them at the same time. No, both of them at the same time. No. It has to, you guys, it has to be in circle A and B, both. Just B, that's it. B over A plus B plus C plus D. Why does it have, why is it just B? That's the only thing that's in both circles, isn't it? Remember, it's an intersection. It has to be in both circles at the same time. It's an intersection. Okay, Chase got that one. Good job, Chase. All right. Let's do this one right here. The third one, probability of A or B. Now, you guys, we learned about the word or. What is the word or? What's its symbol look like? It's a U. It's called a union. It means it can be either or. It can be in either one of them or both of them at the same time if you want. Okay, so I want you to write down what you think the probability is for this one. By the way, an example on that last problem we did. Those of you who tried it, even though some of you guys put A plus B plus C over A plus B plus C plus D, when I told you the answer, you kind of understood a little bit better. When you try and think about something, it makes sense when I explain it. If you haven't tried thinking about it, then it's going to be harder for you to do. So try it first. I'm going to give you 15 more seconds. Okay, everybody that thinks they've got an answer for this one, raise your hand. Even if, just raise your hand if you've got an answer. I want to see who's thought about it. Okay. All right, Chase is looking pretty confident. What do you think? That is correct. You guys, A plus B plus C. If you choose A, B, or C, it's going to either be an A or B, isn't it? If I choose a number over here, it's going to be an A. If I choose a number over here, it's going to be a C. If I choose a number here, it's going to be in both of them, but it only has to be in one of them, but it's okay if it's in both of them.
It just says A or B, not in both of them.
But yeah, but if I said, well, and it's okay to be in both of them. It just has to be at least one of them. Think of it that way. At least one of them. Okay? It can be more than that. Okay? Got that? By the way, you guys, do you understand what A plus B plus C plus D is? It's the sample space. It's all of them. Remember, when you do probability, it's the number of desired outcomes over the possible outcomes. The sample space represents all the possible outcomes that you can get. Okay? Let's go to problem 4 of that one. Problem 4. And that one is asking for probability of A plus the probability of B minus the probability of A and B. Now this one looks hard, but we've already done the probability of A and B, haven't we? Okay, so we already know that the probability of A and B is B over A plus B plus C plus D, right? So what we have to do is find the and we've already found the probability of A. What was the probability of A? It gave it to us right at the first. What was it? A plus B. It's right there. Probability of A is A plus B, upper right-hand corner. So this one is A plus B over the sample space, A plus B plus C plus D. By the way, and then probability of B, what's the probability of B? We've already done that one. No, where's the probability of B? Right here. B plus C. over A plus B plus C plus D minus the intersection. What is the intersection? B over A plus B plus C plus D. Now, you guys, how do you add fractions? What do you do when you add fractions? You get what? You can't add them together until you have what? A common denominator. That's good. Do we have a common denominator here? So then what can we do? Add the top numbers, right? A plus B plus C minus B. That's right. You got it right there. That's going to be A plus B plus C all over A plus B plus C plus. Well, all we did is added the tops. A plus B plus C minus B. Well, there's an A, two B's, and a C. And then you minus a B. So now there's only one B. See, that's going to add these two together, you're going to get A plus 2B plus C. If you minus a B, now you're back to 1B. Got it? And there's our answer for that one. Okay, now the last part B of this whole thing, asks us, what is the connection between P of A or B, which is problem 3, and then problem 4? Probability of A plus probability of B minus probability of A and B. What's the difference? What do you think? What was our final answer, you guys? On problems 3 and 4, what were our final answers? What was our final answer on 3? A plus B plus C over the sample space. There is no difference. They are the same thing. That's what I want you guys to see. On number 7, 3 and 4 were the same problem. Okay? All right. Now, you guys, we don't have the rest of problem 8 to do it, so cross that one out. We're not going to do problem 8. Okay, now, how many of you are done with this worksheet? Okay, good. All right, I'm going to let you guys have some times at the end of class to do it today. What we're going to do right now is we are going to answer this question, and then we're going to make 2 tables where we're going to actually roll some dice and figure some stuff out here. Huh? We're just going to answer this question. It'll take us about 3 or 4 minutes, and then we'll be done, okay? All right, you guys, remember the other day when we rolled the sum of dice? What's the possibility of getting a sum of 2? 1 plus 1 is 2, right? 1 plus 2 is 3. Did you guys all write this down in your notes at this table? 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6. 1 plus 6 is 7. Does everybody have this chart down? I want you to quickly fill it out. Again, if you haven't written it down. 2 plus 1 is 2, or is 3. 4, 5, 6, 7, 8. Go ahead and finish filling it out. All right, let's answer this question, you guys. Describe the event that summing 2 rolled dice is larger than 7 and even. How many up here are larger than 7 and even? What do you think? Which numbers are larger than 7 and even? Okay, 8s, all the 8s, all the 10s, and the 12, right? How many total numbers are there? How many total did I circle? 9. So what's the probability of rolling a number larger than 7 and it's even? 9 out of 36. And what does 9 out of 36 reduce to? 9 will go into both of these numbers. 3. Okay, it reduces to 3/12, which reduces to what? 1/4. So you guys, the probability, it actually is just actually for the event, which would have just been 9. The event that it could happen is 9. But if we write it as a probability of 9 over 36, we get 1/4, right? Do you guys remember how to do that?
Yeah.
So, because there was 36 possible outcomes right here, and 9 of them were our desired outcomes. Okay, what's the difference between that and the event that the sum is larger than 7 or even? Larger than 7 or even.
So those that are larger.
It's got to be larger than, if any number that's larger than 7 or that's even.
So 9 and 11.
So yeah, see if you can figure that out. Think about that, you guys. If you process in your brain, you're going to get it. Only about half of you guys are processing it. I'm looking down at you.
36 and 9.
Well, how many of these numbers up here?
2, 4, 6,
How many numbers are larger than 7?
8, 9, 11.
No, in this chart right here.
4.
8, 9, 10, and 11, right? So all of these, how many total are there? There's 15 that are larger, but it says also or even. Okay, Nicole's got it. Or even would be all those numbers as well, right? And Nicole's, notice that there's 24 of them. 24 out of 36 would reduce to what? 12 goes into 24 how many times? Twice. How many times will 12 go into 36? 3 times. So there's a 2/3 chance. Which one's the greater chance of getting? The first one or the second one? The second one, right? Okay. Gabe? Gabe, don't talk. Thank you. Okay, it's better to get the second one. Now, I want to show you guys that this can be written as a Venn diagram. Okay? We're going to write another Venn diagram right here. Everybody write this Venn diagram. I want you to understand this. We gotta get these Venn diagrams down. What do you think one of the circles is going to represent?
The numbers that
7 and another one's going to be evens.
Okay, one's going to be evens. And what's the other one going to be?
Above 7.
Numbers larger than 7. That's right. Numbers larger than 7. Okay? Now, you guys, how many numbers are going to go in this intersection spot? How many numbers are larger than 7 and they are even?
3, 8.
Let's go back and look. How many of these were larger than 7 and even at the same time? How many were there? There were 9 of them that were larger than 7 and they were even, right? Okay, so we're going to go back here to this thing. There's 9 that are larger than 7 and even. Okay? No, we're just doing how many there are. We could put, there's 2 different ways to do Venn diagrams. You can actually put all the numbers in that go in there, or you can just count how many there are and put them in there. Okay? So, if we go back here again, how many numbers are larger than 7 but not even? How many numbers are larger than 7 but not even? How many do we get larger than 7 but not even? 1, 2, 3, 4, 5, 6 of them? All the 9s and 11s, right, are larger than 7 but not even. So we're going to go over here and put 6 right here. Well, we're going to, okay, how many are even but not larger than 7? We're actually doing different numbers in here. How many numbers are even but not larger than 7? Okay? Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them, right? The 2s, the 4s, and the 6s. Did you say 9 of them? So how many total are inside here, you guys? 9 plus 9 plus 6 makes 24. So how many, Shania, are not in either one of these circles? Someone said 12. That is right. There are 12 that are not larger than 7, nor are they even. You want to go see which ones they are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All the 3s, 5s, and 7s. They're not larger than 7, and they are not even. Okay? And there is a Venn diagram that can represent that information right there. So do you guys understand that what goes inside this right here, the intersection, is what satisfies both at the same time? That's what you need to know. Okay, now, you guys, we're going to make everybody's divided up into pairs right now. Something up there. Okay. It's biology class above us, so you never know. Okay. What we're going to do, as everybody, I want one person in each pair to draw this really quickly, a 12 by 3 grid. Quickly draw a 12 by 3. I didn't need this last row, by the way. I didn't need that row. Draw a 12 by 3 grid and put these numbers and tally and total in there. Really quickly. Quickly. One person from each pair. I'm not going to leave it on the screen for very long, so quickly do that. One person from each pair. Both of you guys are going to be writing things down during this. Okay? I would suggest you do it on the same piece of paper, or if you're opening up a notebook, one on one piece of paper, one on the other, so you can see them both at the same time. It'll be a lot easier to do what we're doing if you do it that way. Okay? Who's got it written down in your group? Nicole and Sarah. One of you are supposed to have written that down. Okay, you got it? Make sure you write the grids and everything. 3 columns and 12 rows. 3 columns and 12 rows. We got that? Okay, now I need you to write one like this. I need you to write one that has, this one's going to be 3 by 22. It's really long, right there. This is the possibilities. When you roll your dice, you can get a 1 and a 1, or 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. Or a 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Or 3 and 3, 3 and 4, 3 and 5, 3 and 6. Or 4 and 4, 4 and 5, 4 and 6. Or 5 and 5, 5 and 6. Or 6 and 6. That takes care of all possibilities. It's a 3 by 22. 3 columns by 22 rows. That was on the first one.
We're making 2.
Yep, you're making 2 of them. They got to be side by side, or they want to be on the same piece of paper or on opposite papers where they're in your notebook. So you got one page open and the other one right there. Okay? Now, guess what we're going to do? You are going to roll your pair of dice 100 times. Okay? Chase had it in my mind 1,000 when he said that. Okay, now this is what you're going to do. Everybody right now, one of you roll your pair of dice. Just roll it. Okay, now I'm going to do one example. Okay, so okay, right here, Natalie got 3 and 3. So I'm going to mark it on this one right here. I'm going to put a tally mark. 3 and 3. And over on this other one, she got a sum of 6. So I'm going to put a tally mark on a sum of 6. You guys all do that with yours. So if you're not sure what you did, ask me and I'll tell you. It's just every possible situation. You can get a 1 and a 2. Clear down. Yeah, you have to write those down. I need to keep them down there? Yeah, you have 2 tables. This one's 3 by 22. So 3 rows by 22 columns, and you're going to have these numbers.
You gotta give us a minute.
I know. I'm giving you a minute right here. Well, why does it start 2 and 2? Because I already have a 1 and a 2. I don't need to write 2 and 1. Because 1 and 2 is the same thing as 2 and 1. Because it doesn't matter the order. If you get a 1 and a 2 or a 2 and 1, I'm going to count that as the same thing, okay? Got it? If you got 1 and 2 and 2 and 1, 4 and 1 and 1 and 4 are the same thing. That's why, since I already have 1 and 4 listed right here, I don't have to have 4 and 1 down below. That's why all the ones that started with 1, there were 6 of them. All the ones that started with 2, there's only 5 of them, right? 4, 4. There's those right there. I already did this year. I only do one song a year.
I didn't sign up for this class for one song.
I'll tell you what, if Sarah will get up and sing a solo, really good one, I will do one too.
Wait, did you put a 2 after?
Anthony, please no. Huh? 2, 2. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Okay? Who doesn't understand what we're doing yet? I'll give you an example. Okay? Cody, roll your dice. What'd you get? A 5 and a 1. So I would go to the place where I have a 5 and 1, and I'd put a tally mark. Whoops. Tally mark right there. And then I would go to this one. 5 and 1 makes 6, so I'd put a tally mark there. Okay? Do you understand? Who else doesn't understand? Shania. Okay. This is really important, what Shania just asked. And I kind of told you already, but I need you to keep track. So one of you is doing the tally marks on this, while the other one's rolling. The person who is rolling is also going to do a tally mark. We're going to roll it a total of 100 times. And I want you, every time you roll the dice, I want you to put a tally mark. And you're going to just do this, and there's 5, 10, 15, 20, and so forth till you get to 100. That way you don't have to go through and count your tally marks on the other thing that are not in 5s. Okay? I would suggest doing them in 5s if you get more than 5, but because you'll get confused. You won't remember. Okay, so you guys, I'm going to use these two as an example. Okay? Chase is going to roll the dice. Go, roll. Chase got a 5 and a 4, so she's going to put down a tally mark on 5 and 4 and on 9, because 5 plus 4 is 9. So 5 and 4. It doesn't matter. There's only one up there. 4 and 5, 5 and 4 are the same thing. So one tally mark, and then turn it over, and they add up to 9, so put a tally mark on 9. While Chase is going to put a tally mark that says they've rolled the dice once. Okay? All right. You guys got 10 minutes to do this. Go. Hey, everybody, look up here. I want you to do this now. Hey, even if you guys are still rolling. Sarah, please. Shh. Listen, you guys. Okay. Even if you're still rolling, you're not done rolling your dice. I want you to do this now if you are done or when you're done. I want you to calculate the actual percentage of each outcome rounded to 2 decimal places. For example, let's say on your 7s, your sums of 7. This is just on the first chart, the one where it had sums 2 through 12. Let's say on your 7s, let's say during that time that you actually rolled 18 of them, okay? Now, you rolled 100 times, right? So 18 divided by 100 is 0.18. You change that to a percentage by timesing by 100, you're going to get 18%, right? I want you to write the percent by each one. Got it? That should be easy since we divided by 100. Since we did 100 times. What was that? Yeah, probably not today. Okay. Yeah, so let me look at yours for one example. From this one right here. You guys, the number comes from your first chart, the one where you summed them up. Like these guys on 3, they got, is that 6? These guys got 6 on number 3. So their sum of 3, they went 6 over 100 is 6%, right? Because we did it 100 times. This is real easy. 6%. Just if it's 18, it's 18%. Yep, if it's 2, it's 2%. It's pretty easy. You're going to divide it by 100 and times it by 100. Got it? It's going to be a percentage. Okay, do that for right now.